All right, class.
Yes.
Thank you for the people that show up on time. Everyone else. Yeah. So, if you're paying attention, this is going to be on what page in my notebook? Now, along with the notebook thing, a lot of people did not put their name on it. They didn't do any type of cover or even write their name anywhere on it. Can you believe that? It's almost like 6 weeks. I was telling people to do that, and I still have over 20 of them with no name on it for some reason. So, if you have something that says no name, that means I don't have a name to go with your score. If you're one of those people that decided to not even do it, okay, you have no score anyway. But you want a grade here. So this is going to be page 19 in my notebook. 19 in my notebook. Everyone is going to write page 19 on this because a lot of times this should not take this long to grade notebooks. It really shouldn't. I got a problem because people don't put things where they go. There is a couple rolls of tape, around here somewhere. Tape in your notes. Tape in your work. Put it where it goes. Do not be that person that folds everything up and sticks it in the notebook because I'm not going to unfold it. If it's not there for me to look at, then you get no points. I've said it many times. Anyway, there's one that someone actually just folded all the notebook pages, and they I was like, no, I'm not going to go back through that. No, it just makes more work and effort for me. I don't want to do that. I really don't. Because you ain't heard from me. I don't want to gossip. So, linear programming. This is important. We're going to have this lesson here today, and I need you guys getting full attention because this is where you're going to fail. On these problems is where people fail because you're not paying attention. You are scrolling through your feed, you got earbuds in, you're not paying attention, and I'm doing my best to make you pass. And it's kind of hard to do that when people are just going to their phone, getting distracted. Stay focused on this. This is not an easy lesson. I need you to stay focused and actually pay attention for the entirety of the class. What we're going to be doing here is we're going to be maximizing or minimizing an equation. So it is a word problem, and that's where everyone has the problem with it. Okay? A lot of people, English is their only language. But imagine people that don't speak English, and they're trying to do these word problems. That's crazy, right? And it's going to make it even harder. Especially if people are just scrolling through their feed, they got earbuds in, and they're not paying attention. Okay? You ain't heard from me though, right? So, we're going to maximize, so let's say for instance in business. What would you maximize in business?
Money, profit.
Money and profit, right? We're going to maximize profit. What would we minimize? Loss, right? That's one thing. Or minimize the amount of students that have earbuds in. Just because it's in the other ear doesn't mean I can't see it. It's gross. Okay, so you're going to minimize loss or cost. Because by minimizing cost, that will maximize profits. And that's what we're trying to get out of this. So we're trying to put it all together here. And again, this is a word problem where it's going to cause the most trouble if you're not paying attention. All this is referred to as linear programming. Now, this one example goes through the entire set of notes. Every part of these notes are a different part of this same problem. And so that's why I'm going through it piece by piece, and people that don't pay attention are going to be in trouble here. Bottled water and medical supplies are being shipped to victims of an earthquake by plane. Each container of bottle will serve 10 people. Each medical kit will aid 6 people. Let X represent the number of bottles of water to be shipped, Y number of medical kits. Write the objective function that describes the number of people that can be helped. First, this one right here, bottles of water. So every one bottle of water will help how many people? 10. And what am I representing water with?
Eggs.
So together, I would say that would be?
10 eggs.
Good. Perfect. 10 eggs. Now, I'm going to be helping people with medical supplies too, right? And every medical kit will help
6 people.
6 people. And what variable goes with my medical supplies? The Y. So how would I write that?
6Y.
6Y. So I'm adding the number of people, 6Y. So I added 10x plus 6y. And that's going to help the amount of people we have. On this right here, I'm going to represent the number of people to be z. Z is going to be the linear operator for this function. Z is going to represent either the profit, the loss, or the total number out of all of this. In this case, it's going to be the number of people we're going to help. Yes? That's what we're going for. I want the most. So I'm trying to maximize this value here. So my function is z equals 10x plus 6y. That's what you're going for right there. When you set this up, especially the word problem, you have to have it as a z equals and then whatever it is that you're trying to explain. Next part. Constraint. Now, what is a constraint? Restriction, good. Okay, so now, I got one for you. What's the smallest amount of water I could send?
1.
Nope, not 1.
10.
Nope. 0. I can send no water, right? So it is possible to send 0 water. I could send 0 water, but a maximum for the other value, right? I could just send all medical kits, couldn't I? I could. So the restriction here is going to be, can I have negative numbers? I can't have negative bottles of water, can I? No, I cannot. What about medical kits? Can I have negative medical kits?
No.
Isn't that just a poison kit? That's a negative health kit, right? Yeah, it's a poison kit. Mine is 2 to stamina, right?
Yeah.
Okay. So, we cannot have negative. So it's going to be my x has to be greater than equal to 0. My y has to be greater than equal to 0. So those are constraints for this. Because this is going to be a word problem, and I cannot have negative values there. It's kind of like the number of people on a plane. Can I have an infinite amount of people on a plane?
No.
No. Can I have less than 0?
Yeah.
No. I could have a negative passenger
Oh, yeah.
that starts screaming and saying that guy ain't real. But, see what I did there? See what I did? Okay. I cannot have negative numbers of people. So that's a constraint for that one. Now, the second part of this. Now, each plane can carry no more than 80,000 pounds. The bottled water weighs 20 pounds per container. Each medical kit weighs 10 pounds. Let X represent number of bottles of water. Hey, you guys okay back there? And what's it? Medical kits weighs 10 pounds. Let X represent number of bottles of water to be shipped. Y number of medical kits. Now, can it be equal to 6,000?
Yes.
Wait, no, I'm sorry. This is 80,000. Sorry, 80,000. It could be equal to 80,000, right?
Yeah.
Can it be more than 80,000?
No.
No, it cannot be more than 80,000. Can it be less than 80,000?
Yes.
It can be less than 80,000. So my inequality, do you want me to go hold this for you? Because you keep getting distracted for some reason. Can it be less than 80,000? Can it be more than? No, yeah, good. So we're going to write this out. So 20 pounds for every what? Water bottle. What am I representing water bottles with? X. So it's going to be a 20X. Plus the weight of the medical kits. How much does each medical kit weigh? 10 pounds. So it's 10 pounds, 10 Y has to be 80,000. So all that has to be less than or equal to 80,000. Okay. Now I got a story to go along with this. So now I was driving by Walmart the other day and I saw Melvin. He was driving his like Honda Civic. He has an '83 Honda Civic with a hatchback, and he had the spare tire in the back seat. But he got a big screen TV. He got like one of those really big, like 70-inch big screen TVs. His car, you know, the TV only weighs 40 pounds. His car can carry it. But when I saw him at Walmart trying to put that 80-inch TV into this hatchback, is that fit?
No.
Not really, right? I'm telling you, that Honda Civic, you can try and put that hatchback open as much as you can, but it's really not gonna. You can't fit it in there, can it? Hey, you can do that too. You put it on top. Okay. Now, and what's gonna happen when it hits that first bump? Yep. Right there. Now, I've seen many people. Actually, I saw one the other day sitting on the window seat, on the windowsill, like hanging out, like actually hanging his body out the window, and then he was holding onto the TV that was on top of there. Okay, and there was one on both sides holding it. Someone wants to skip that delivery fee, right? Anyway, so what do we have to worry about when we're actually shipping stuff? How am I shipping this? Plane, right? Okay, so now, can it be like Leroy? When I saw Leroy driving down Indian School this morning, he had 14 couches in the back of his truck. He can carry them though, right?
No.
He can carry them. Yeah, he can fit 18 couches in the back of the truck, no problem. He had trouble going under the overpass though. Hey, it works though. But Leroy doesn't have problems with it. Can we strap a couch on the outside of the plane?
No.
No, we can't. We cannot put it on the outside of the plane. So what else do we have to worry about when we're talking about an airplane? We already talked about weight. Capacity, very good. So just like your Honda Civic, okay, you can carry the weight, but you might not be able to fit inside there, right? Okay, so that's what you have to worry about, especially when we're talking about an airplane. So I'm going to back up a little here, right here. So example 3 says each plane can carry a total volume, that's my capacity there, cannot exceed 6,000 cubic feet. So can it be equal to 6,000? Yes. Can it be less than 6,000? Yes. So let's start that one out. Okay. And it says each water bottle is 1 cubic foot. Each medical kit is also 1 cubic foot. So for my water, it's going to be 1 what? 1 what?
1x.
X. Very good. 1x. Because that's my water. Plus 1y has to be less than or equal to 60 or 6,000 here.
So it could be like 3,000 each.
It could be.
How much pounds is that?
But we have to put it into our equation because it has to meet the constraints. My numbers have to be greater than 0, right? My x and y has to be greater than 0. Where'd that show up again? And I have constraints. It cannot exceed this amount and this other amount, right?
Yeah.
So what we're going to do is we are going to use this equation, and this right here is my linear programming that I'm going to use. So I would like for you people, go to the NumWorks calculator, and we're going to enter these two inequalities right now into your NumWorks. Rosmar. Cheese and rice? Wow, you crashed hard. You were already drooling. Man, that was quick. Anyway. All right, you ready? Step by step, how to do it on the calculator. Step by step, how to do it on the calculator. So if you are struggling with this because you seem to not know how to do this in the calculator, I know you can just go back to the video and watch it again, right? Or you can start paying attention right meow. Hello. Who's this? He's not here. Thank you. All right, so let's go ahead and grapher, okay? And okay. So now my first equation was what? 20x? And that's going to be less than equal to, so toolbox, 80,000. Now, this problem right here, especially for those people that never pay attention, is going to be a little bit more complicated because you have to know how to enter it. And now I'm going to show you a new thing on your calculator of how to move your graph around. So this other one was it 1x plus 1y? And that's going to be greater than or equal to 6,000. Plot graph. All right, is anyone struggling with this part?
Wait. I think no, go back.
So it is going to be kind of messy at first, so that's why I'm trying to show this to you. Now, there's neat tricks with the calculator. So this thing right here, I cannot see it very well, so I'm going to start by, I'm going to go up to right here where it says navigate. So we haven't used navigate yet. Hit OK. And I'm going to start arrowing over. But it's still zoomed in too much, right?
Yeah.
Okay, so how do I unzoom it? I'm going to hit minus sign. Yep, keep hitting the minus sign.
Wow. Beautiful. Also, I have a question.
I have an answer.
It's pretty unrelated to the topic, but is this calculator like an actual calculator, like the world?
I have it right here on my desk. Yeah, so this is actually, it works a lot better than the TIs. So, and it's a lot cheaper. So that's the reason why I'm trying to push students to start using this. Especially if you're one of those people that might be going to college.
It does everything that this one does?
It's the same thing. It's exactly the same. Yeah. So listen, if you go to the website, for the one that we're on, you can actually order it and you get a student discount too. But if you like this calculator, that's just trying to help to make sure everyone's actually going to be successful for those few people that are going to college. Use this. It's what I'm teaching you how to do it, and it's easier than the other calculators. All right, so I zoomed in and I kind of got to this point right here. I'm hoping everyone's here now. All right, Reyes, can you hear me? You got your earmuffs on. Is it kind of cold in here now? Okay, all right. So I'm done with my navigator, so I'm going to back that one. And now I'm going to have to find some values for here. So let's go ahead and there we go. I have the intersection now. So I just arrowed over so I could find the intersection here.
How do you find that?
I just clicked on the line and arrowed over until I got them together. So did you go, you can arrow down. So right now I'm on the red line and then blue line. Does that make sense?
That makes sense.
All right, so watch this. I'm going to, hold on. I'm going to snip this. And then I'm going to add it to my notes.
Oh, what's that? Wait. You just screenshot?
Yeah, I did. Shift Window S will screenshot it for you and you can crop it.
You did do that?
No, I'm just showing you because I'm writing on this right now so you can see. So I needed to take this. All right. Now, for all those people following along, I want you to look. The part that's overlapping is going to be in the blue and the red. So I'm going to be right here. I can't have any of the negative numbers, right?
Yeah.
No negative numbers, so nothing below the line. And right here. So it looks like this is the overlapping area. Because I can't have negative x's, right?
Yeah.
So nothing over there is going to exist. Nothing below the line exists. Now I'm going to use that because every vertices, every corner of this shape is going to be one of my values. I'm going to use this point right here. You have your calculator still right there in front of you. Can you tell me this coordinate right there?
0, 6,000.
0, 6,000. Now, this next one right here, where the two lines intercept, what do we have there? It's not 0, 4,000. 2,000, 4,000. Very good. This corner right here, that corner right there, the bottom right-hand corner, what's that going to be? It's not 0. It's 4,000, 0. 4,000, 0. And this one right here also has to count. 0, 0, right? So what I am trying to do, my actual shaded region is going to be all of this inside here will satisfy my system. So it will be true if I use any coordinate inside there.
Oh, really?
Yes. Why are you just wandering up here?
Don't take a picture.
You know it's in the notes too, right?
It is? Why
Yes.
did you say something?
I did.
Thank you.
So, now what we're going to do next is my z equation. And then I'm going to list all my coordinates. 0, 0, 0, 6,000, 4,000, 0, and 2,000, 4,000. Now, what you're going to do is, this is the linear programming. This is where we're going to try and find a value that is going to be a minimum or maximum here. So when you wrote down all those coordinates that you did not do, sucks to be you. I have an x and y. I'm going to plug in the x and y to see what my values are. So, plug in my first one. 10 times 0 plus 6 times 0. Anything times 0 is?
0.
So right there, that's going to give me?
0.
So I could end up helping 0 people. Yeah, that's true, right? Now, you're going to plug in the next one. Plug in the next one. Plug in your x and y for your next one. Plug in the x and y for your next one. No, look at your clock. Start plugging stuff in. Keep going. Z equals. Right, Z equals. Okay, 10 times. What's your next? Right, 0. You're plugging in the next ones. So you're plugging in the next coordinate. 10 times my x, which is 0, plus 6 times my y. Does that make better sense? So you're plugging in the next coordinate and you're telling me what that's going to be as a total. Six times 6,000. Did you get it? Did you get it?
Well, we didn't know that.
All right, let's see. 36,000 for that one. Are you guys okay still? Yes, no? Anyone questions on this one? We good? All right, let's try next one then. Next one is going to be 10 times 4,000 plus 6 times 0.
A lot of work.
You're right, it is. That's almost like we've had this entire lesson to cover one problem and doing every single step for these one problem. Yeah.
How many questions do we have for homework?
You're going to have like 40 of these.
No.
You're right, I'm lying. But I want you to actually, it's not so bad once you actually get going. I'm just trying to go slowly so I don't lose anyone because everyone keeps not paying attention for some reason. They just pulled their phone out and just completely got distracted. It's all right. Summer school's fun after your senior year. So, Z equals 40,000. And my last one, 10 times 2,000 plus 6 times 4,000.
Oh, right on.
10 times 2,000 is
24,000.
20,000. 6 times 4,000.
800.
You just said 800.
No.
That one's 2,400. So together, 44,000. So I'm looking for this. 44,000 is going to be my what? You're trying to optimize this, right? Very good. That's going to be my max. And then if I was asking for a minimum, my minimum would be
0.
So in your problems, you're going to have to do both. Okay? You have to get used to solving for one or the other. It's not always maximum. Sometimes it's going to be minimal. That makes sense? Yes.
Is there ever going to be a question when the minimum is less than 1? Oh, I mean, it's less than 0.
Now, in a real world problem, do you think we would actually have negative values? It depends on the context of my problem.
Yeah.
So that's why. Because I know that this one's already a complicated problem, I left these in here so you could see this. Right, Melvin? I left all this in here so you could see this in the notes. Because people keep getting distracted. Now, in context, what does that mean in context? What does the 44,000 represent?
Pounds.
Nope, try again. People. Was I trying to help people?
Oh, yes.
I was trying to help people. So I helped 44,000 people by sending what? Water. How much water did I send? 2,000. That was my X value, right? 2,000 water bottles. And what else did I send? 4,000 medical supplies. So in context, that's what that means. Maximum number of survivors to be helped is 44,000 by sending 2,000 water bottles and 4,000 medical kits.
Right there.
It is right there. It's almost like I put it in the notes, but some people don't write down notes, so I know that this one's already really complicated. So I made sure I wrote it down for you because for some reason some people can't seem to still pay attention. But you ain't heard it from me. I ain't want to gossip. But people that don't listen to me. All right, so this is what we are going to do. You're going to use the rest of this time right now, which is another 15 minutes of class. Like, share, and subscribe.